Welcome back to question 2 of this series, where we learn how to graph a cubic function without the use of a calculator. Once again, we're expected to graph a particular function. In our case, we have x to the power of 3 plus 2x squared minus x minus 2. And we'll start with their first requirement, which is to factor the function. Now, to factor this function, we'll factor by grouping. And what we have here are 4 terms. And I'll factor these two, and I'll factor these two. Let me demonstrate what I mean. Notice that both of these terms have a common factor of x to the power of 2. So we can rewrite this as f of x is equal to x to the power of 2 bracket x plus 2. And over here, there's a common factor of negative 1. So I can pull that out, leaving me with x plus 2. Now notice, this and this are alike, and they can also be factored out, leaving you with x plus 2 in brackets, and what you're left with is x squared minus 1. This binomial is also factorable. In fact, it's a difference of squares. Notice that both of these terms are perfect squares and they're being subtracted. Therefore, I can break this down further into x plus 1 and x minus 1. In question B, they say find all the zeros. Now you can find the zeros of a function by setting it equal to 0. So I'll set this equal to 0 and subsequently solve each of these factors individually. If I solve for x here, I end up with x is equal to negative 2. Over here, x is equal to negative 1. And over here, x is equal to 1. This leads me to 3 points. Our roots are negative 2 and 0, negative 1 and 0, and positive 1 and 0. And they also ask for the multiplicity. In question number 1, we discussed what multiplicity is, and I have a definition right here. In case you forgot, multiplicity means how many times a particular number is a 0 for a given polynomial. Since each of these factors have an exponent of 1, the multiplicity is 3. For a more detailed explanation of this, refer back to question 1. We discuss it further there. Next, in question C, they want us to find the domain and range. Now it turns out that anything you put into x, any real number, will give you an output. This means our domain consists of all real x values. In addition, any value that you put into x will give you a y output, and that ranges from negative infinity to positive infinity. So also your range consists of all real y values. So question C is done. Let's move on to D. D asks us to use the y-intercept, the x-intercepts, which are right here, and other properties of the graph to sketch this function. Let's start with the y-intercept. Just like in question number 1, the y-intercept is found by setting x equal to 0. So if we set this x, this one, and this one equal to 0, we're left with negative 2. So our y-intercept is at 0 and negative 2. Now they also discuss properties. There was one property that we discussed in question 1, and it was that if your leading coefficient is negative, in our case it's positive, but if it's negative, the curve starts at the top left corner and it makes its way down to the bottom right corner. Now the opposite is true if it's positive. So in our case, we should expect something that starts in the third quadrant. Let's say that's an xy plane. It will start here and end here. So keep that in mind when we plot. We'll go ahead and plot these points. We have a point at, and I'll use 2 blocks for every one. So that's negative 1, that's negative 2, that's 0, and this is positive 1. I'll have a point right here, a point right here, and a point right here. The y-intercept is at 0 and negative 2. That should be right here. Since that's negative 1, this will be negative 2. Also, the leading coefficient was positive, so we should expect that our curve starts here, makes its way through this point, then through this point, down to the y-intercept, up to this point, and onwards. So let's draw a curve that passes through this point, and we can assume that it will reach a peak somewhere in between negative 2 and negative 1. And if you want to be really precise, you can create a table of points and see where it will reach its maximum. But let's just assume that it makes its way up and down through here. Then it passes the y-intercept, back through the last x-intercept, and up it goes. What you see in black represents the curve or a sketch of the function that we started with. And there you have it. That is how to graph a cubic function. Make sure that you watch question 3 for the most difficult question of this series. We'll see you soon.